Welcome back to part 3, our third video as we go over the practice test in geometry for the first competition of the Catholic Math League. We left off at 15 and 16, which were definitions. So those were two quick problems. Let's move on now to problem number 17. In number 17, we have an area that we need to find. We could see, similar to the previous problem that we did with an area, that we have a larger area minus a smaller area. I knew that was going to happen. Get my pen back. It's a little hard to do this. Okay, here's my pen. So we have a larger rectangle, which has length 8x and width 6x, and we're going to be subtracting the area of the smaller rectangle. So I'll call the larger one rectangle 1, and I'm going to be subtracting from that the area of rectangle 2. So these are areas that I want to indicate here. So the area of a rectangle is length times width, so I have 8x times 6x. But my inner rectangle here is going to be 2 by 3. So that's just going to be 2 times 3, or 6. So I have 48x squared minus 6, and I could see that my answer is right here at E. Okay, we have number 18. Two acute adjacent angles will blank be supplementary. Okay, what does an acute angle mean? An acute angle is less than 90 degrees. So for number 18, we have something less than 90 plus something less than 90. Let's look. Will always be supplementary? No. Usually, sometimes, seldom, never. Never can you add two numbers less than 90 and get a number that's equal to 180. Moving on to number 19. CE is equal to 12. So let's label that. ED is equal to 12. So we must have a bisector there. BA must be a bisector. BA is perpendicular. BA is perpendicular to CD, so it's a perpendicular bisector. Which of the following cannot be proven? Okay, BA bisects CD because they're both 12. We said that's true, so this is true. AB minus BE, let's look at that. AB minus BE, well, that's a line segment, so we have the addition of line segments. So that must be true. CD is a perpendicular bisector. CD is a perpendicular bisector. That would imply we'd need for this area BE to be equal to EA, and we don't have that. We do not have that. We could go on just to check and make sure. E says all statements are true, and we're thinking that C is not true. D says CE is half of CD, which we know is true from the given information. So our answer is C. Number 20 seems to be another definition. What special name does AB, line segment AB, have if CB is equal to DB? CB is equal to DB. Right there. So it's cut right here by line segment AB. We don't know it's an altitude. We're told nothing about height or perpendicular. We're told nothing about perpendicular. We're told nothing about the angles. But the fact that it cuts a line segment in two means that it's a median. And that's a definition that we should know. Number 21. What is the ratio of 11 hours, 59 minutes, and 60 seconds to 1 week? So we're doing another ratio here. We did a previous problem with a ratio. Whoops, that moved me up again. for number 21, let's do this ratio. We have weeks. And we have hours, minutes, and seconds to 1 week. So we want to get everything down to the same unit, to the smallest unit. So weeks, 1 week. In terms of seconds, well, I know there's 7 days in a week. I know each one of those days has 24 hours. Each one of those hours has 60 minutes, and each one of those minutes has 60 seconds. I'm not multiplying this because I'm going to be reducing. So 11 hours is 11 times 60 minutes times 60 seconds, all in terms of seconds. 59 minutes is 59 times 60 seconds. I'm not going to be multiplying all this out. And then I have 60 seconds. I could see that 60 is common, a common factor. So I could factor out a 60. I still have 11 times 60 plus 59 plus 1 now. Look at that. So I'm going to cancel one of my 60s here. So I'm really left with 7 times 24 times 60. 59 plus 1 is another 60. So I have 11 times 60 plus 60. I'm going to factor out another 60. When I factor out another 60, I have 11 plus 1. Now my denominator here, I have 60 over here, I have 24, and I have 7. So the 60s are gone. I have 11 plus 1, or 12, over 24 times 7, and I'm reducing that to 1 and 2. I have 1 over 14, and I'm hoping I see that up here, and I do in B. Let's see if I'm going to have enough room for number 22. I might need to erase some things. If I put 22 here, I'm talking about the surface area of a cube. Now a cube has 6 faces, and the surface area of a cube is 6 times the area of each face. So if the original cube is x by x, then 6x squared is the surface area. Now they're asking me to triple each edge. So instead of being x and x, it's going to be 3x and 3x. So now my new surface area is going to be 6, because there are 6 faces, times 9x squared, which is 54x squared. How many times bigger is 6x squared than 54x squared? How many times bigger is it? It's 9 times bigger, so my answer is C. So again, you can pause this video and go back to see where I did the work here. The work for 22 is here. Originally, I used x and x for the dimensions, and then when I increased the size for my new surface area, I used 3x and 3x. Again, you can pause the video and go back, and you can message me if you want to go over any one of these problems again. Numbers 23 and 24 seem to be in a similar vein to the previous problem. Okay, so for number 23, we're told if you double the length and width of a rectangle, how many times larger will the area be? So let's look at a rectangle with width W and length L, and we know the area is L times W. Now I have a little bit more room here, but nothing's being drawn to dimension. But they're telling me if I double the length and double the width, what happens to this area? The new area will equal 4LW. Compare those two answers. How many times larger is 4LW than LW? So our answer is 4. Let's take a moment and read number 24. If each base of a trapezoid is doubled, how many times larger will the area become? So let's draw a trapezoid and remember the area of a trapezoid. Here's a trapezoid. A trapezoid has two bases, like base 1 and base 2. And if you don't remember, it has a height. This is there. And the area of a trapezoid is the average of the bases. So B1 plus B2 over 2 times the height. We could actually piece this together and make a rectangle out of it if we move this little triangle over to that side. Okay, so that is our formula for the area of a trapezoid. If each base is doubled, how many times larger will the area be? So what we're going to do is we're going to consider the new area to be the same height times 2B1 plus 2B2 over 2. Let's compare. We could factor out the 2 here so that we just have an area that's the height times the sum of the bases. How much bigger is the height times the sum of the bases than what we originally had, which was 1/2 the height times the sum of the bases? I am just factoring out the 1/2. Let's compare. If each base of the trapezoid is double, how much bigger is 1 than 1/2? It's twice as big, so our answer is 24 is A. For the last problem, number 25, we need to know what the volume of a cylinder is.